So hi everyone, I'm Kostas Kremizas, and this is Eleni, wait for it, Papanikolopoulou. So don't worry, her name is going to be the most difficult thing in this whole presentation. We're both iOS developers at Workable. Workable is an applicant tracking system that helps companies streamline their hiring process. And we're here today to talk about error handling. Not because we're some weird kind of developers that like dealing with errors more than we like building great features, but because while we were developing our mobile apps, we came to the sad realization that it was not so easy as we thought it would be, and we would actually have to design for errors in order to be able to create applications that had many features and many screens, and at the same time would provide a good user experience. So first, we're going to talk about the most common problems that developers face while writing error handling code. And then we're going to talk about a way that worked for us in order to reduce complexity while doing error handling. So let's start with some definitions. As Matt Gallagher, who gave an excellent talk yesterday, says in his blog, an error is a value used to report that an error condition occurred and normal functionality was skipped. And error handling is code that looks for errors and performs different actions based on the presence of those errors. In other words, error handling is the art of failing gracefully. So why should we bother with looking at errors in depth? First of all, as our applications become more and more sophisticated, they become an even more important part of our everyday lives. We're using them to do trivial stuff like post silly pictures of animals on the web, to more important stuff like submitting health records or making transactions. However important those actions may be, they're not guaranteed to be successful. And that's because applications often rely on resources that are, well, unreliable. One example is internet connection. Many applications need the internet in order for them to function properly. But unfortunately, as we all know, internet connections are not reliable, and especially if you're a mobile user and if you're on the go. So it is very important that when user actions actually fail, that applications handle them in a smooth way. Otherwise, it's very likely that users will become frustrated and will lose their trust in our app and will stop using it. And it doesn't matter if you put tons of work into creating great user experience with animations and stuff like that. It only takes a few instances of bad error handling during a very important user action for the user to lose their trust in your app. For example, imagine the user of this application. They went through the trouble of downloading this app through the App Store, went through the pain of creating a new user account. They trusted this application with their credit card info, and actually decided to buy something that is fairly expensive with this app, only to be left wondering what exactly went wrong. Like, was my credit card charged or not? And what can I do to learn more? Oops, something went wrong is not enough for them. So this begs the question, how did the developer of this application let this happen? It seems that just a more explanatory error message would do the trick here. And we see this all the time with applications that either don't provide any feedback to the user at all when something goes wrong, or provide very confusing error messages. So it must be that the developers of these apps are just lazy or don't care about their users, right? Well, not exactly. So let's get on to the details to see why this happens. In theory, the steps you have to follow in order to add error handling to your application are very simple. For each method that can error out, and the Swift compiler helps a lot with that, with defining these methods, first you have to list the possible errors that can be thrown, and then for each one of them, you have to decide if you're going to propagate the error any further, or if you're going to handle it and how. When listing the possible errors that a method can throw, it's very helpful to divide them into two categories. First, we have technical errors, which are errors that occur while the user is trying to do an action that relies on a technically unreliable resource, like we said before. And usually, the developer bumps onto them when using Apple frameworks, like Foundation Framework. They have nothing to do with the business rules of the application. They can happen across all apps. Examples are network connection failed, or file not found, or the server is unavailable. On the other hand, we have business errors, which are actually errors that developers decide to create themselves in order to denote that the current state of the application has deviated from the happy path, and this has to be handled. Of course, this is very closely related to the business rules of each app. Examples of business errors are authorization errors, validation errors, and stale or bad data errors. So after we have listed the possible errors, we have to handle them. Usually, we want to update the UI to indicate to the user that something has gone wrong and let them know if they can do something about it. Additionally, sometimes we want to do something in the background in order to restore the application to a functional state. And almost always, we want to log the error information either to the console or using a remote error reporting mechanism like Crashlytics in order to help debugging. So we've seen that there are a few things that we have to consider while preparing for error handling, but it still doesn't seem so complicated. But as someone with an even more unpronounceable name than Eleni said, in theory, there is no difference between theory and practice. But in practice, there is. So let's see a real-world example in order to see what difference between theory and practice.
So let's assume we want to create a shiny new email client app that will make sending emails a very delightful experience. So let's say we have done all the work, we have implemented all the functionality, apart from one trivial detail. We haven't dealt with errors yet. So let's try to add error handling to our app like we would normally do. For this case, we imagine Unlucky Bob, who is our target user. So Unlucky Bob has learned about this amazing new app, and he wants to check for himself what all this fuss is about. So he downloads the app, he creates an account, and he tries to log in for the first time. But Bob lives a very complicated life, and he has much in his mind. Therefore, he forgets his credentials. So what our app should do in this case is to show him an alert that he has provided incorrect email or password. So what is the code that we need to write in order to achieve this? In our login controller, at the point where we handle the login tab action, we make an asynchronous call to our login endpoint. And we get a callback with a response and an optional error. And if the error is not nil, we can use pattern matching in order to catch the error. We know that we will receive an unauthorized HTTP error with status code 401. So we match the error and we show the alert. So Bob tries again, but this time he has a poor network connection. So our app should guide him to check his connection and try again. So we know that we will receive an error of type NS error with the specific error code. So we catch the error and we show the warning. But Bob is really, really unlucky. So this time he provides a syntactically invalid email. And assuming that we haven't implemented client-side validation yet, we know that the server will return a custom sign-in error. So we catch the error and we update the UI at the exact point where the email text field is. Finally, we want to have a fallback scenario. We want to have a generic error message for every possible unknown errors in order to let Bob know that something went wrong. So we add this to our default case. And finally, we want to log the error in any case for debugging purposes, as we said before. So this is the code we wrote in order to add error handling to our login screen, like we would normally do it. So let's say that Bob finally managed to log in, and he has been using the app successfully for some time. At some point, he wants to send an email, so he goes to our compose email screen, and he tries to send an email to Natalie Sung, who happens to work in the customer support department of a retail company, in order to ask her something about the recent purchase he just made. So he writes the email, and he presses the send button. But for some unknown for some unknown reason, he gets an unauthorized error. So what we should do in this case is to redirect him to the login screen in order for him to be able to re-enter his credentials and log in back. So the code we need to write for this is the following. At the point where we unwrap the error, we cut the unauthorized error, and we show the sign-in screen. This time, Bob managed to log in at once, and he goes again to the compose email screen and tries to resend the email. But again, he has a poor network connection. So what we have to do here is, again, to catch the error of type NS error and show the warning. Finally, we want to have a generic error message for every unknown error. So we add it to our default case. But what we have to do differently in this case is that we want to show a message that the draft has been saved in order to reassure Bob that he hasn't lost his email data. So we show this message. And again, we want to log the error. And this is the code we wrote in order to add error handling to our compose email screen. So what we have so far is these two screens, and we get to have a lot of duplicate code, like the offline error and the generic error message and the login of our error. But what we also have is different handling for the same type of error, the unauthorized error. And these are only two screens. But our app, unfortunately, does not have only two screens. Our app has many screens and many more screens. And imagine the error handling code that we need to write in order to add error handling to all of these screens. Probably at the end, we will end up looking like this. So we end up with a lot of boilerplate code, a lot of repeated code, and since we don't have a standardized way of handling the errors, we have to put a great amount of thought in order to decide how to proceed in each error. And let's say that we don't have all the time in the world and in order to deal with errors. And the next feature release is approaching, and we are already behind. And we start telling ourselves that Bob is only a corner case of user. Actually, he's not even a real user. We just made him up. And we start skipping cases by handling them with generic error messages. Or we start copy and paste error handling code all over the place, telling to ourselves that we will come back later, perhaps after the feature release, and we will clean it up, which, let's be honest, no one ever did. Or since the majority of our calls come from the majority of our errors come from the calls to our servers, we handle the errors exactly at the network layer, which is also wrong. All of these are obviously bad practices that can lead either to messy, unmaintainable code or to bad user experience with cryptic error messages like the one we showed before. So what we ideally want? A burger. Well.
No, even though I would kill for one right now, that was not exactly what I had in mind. What I was thinking instead, like, wouldn't it be great if we could make error handling as natural and expressive as ordering a burger? A burger is one of mankind's most delicious achievements. And at the same time, it is a very complicated thing if you think about it. You can have a very wide variety of ingredients, and you can combine them in many different ways, so possibilities are endless. But no one seems to be having any trouble ordering a burger. And no one actually tries to order a burger by exhaustively listing all its ingredients. What people usually do when they visit a burger house is they might say, if they're very frequent there, I want the usual. Or I want the cowboy burger from the menu. Or if they want to change things a bit, I want the cowboy burger with extra bacon without the onions. So how does this translate to errors? What we actually want is a good set of defaults for errors that happen throughout our application. And an easy way to customize these defaults by adding new cases, overriding existing ones, handling errors that are unknown, and adding actions for all errors, like we have to do with logging. While developing our iOS app, we created a lightweight application called Error Handler to help us deal with all these problems that we talked about before. So Error Handler basically provides a declarative API that helps you describe error handling rules in a natural and expressive way. So let's dive into its basic API. Most of the functionality of the library is enclosed inside the Error Handler class. Using an Error Handler, you can add actions, which are basically closures that will be executed when an error matches, meaning a matches closure returns true. You can also add actions that will be executed for any error. You can add actions that will be executed when there is no match. And the way to handle an error is to pass it in the handle method of the error handler. There are also many variants of the onMatchesDo action that help us deal with most common errors. One of them, for example, is this one here that helps us deal with equatable errors. So describing error handling rules looks like this. It's a simple chain. It starts with adding the rules with each on method, and then ends with the handle method that actually handles the error. So what is a strategy in adding error handling across an app? Usually we want to, at one place in our application, we want to set up a default error handler that will be responsible for knowing how to handle with most common errors. Then, at each point where we actually want to handle an error, we can either use this, create this default error handler and use it as it is, or we can customize it and then use it. That means that in many cases, all the error handling code we will need is just this, one line of code.
And Leo agrees. So back to our example. What we saw before is that we had a lot of duplicate code between the two screens. So let's try to factor out this code by using the default handler. So we create an instance of an empty handler, and we start adding him the actions for the most common errors, like the offline error we saw before, and the unauthorized error. In most cases across our app, when we have an unauthorized error, what we will want to do is to redirect the user to the login screen in order for him to be able to re-enter his credentials and log in again. And we always want, in any case, we want to log our error. And if the error does not match any of the before declared errors, we want to have a generic error message. So this is the code we need to write in order to create a default handler, which is pretty much like the cowboy burger. It has all the default ingredients, all the default actions. So let's try to use our default handler in order to add error handling to our login screen. So when we make the call, and at the point where we unwrap the error, we create the default handler, and we add the unauthorized error in order to show the alert. Here, we notice that we return a stop matching value. So matching policy is actually an enumeration with two possible cases, a continue matching and a stop matching. we use the continue matching value when we want the specific action to be executed for the specific error, plus all the matching actions that have been declared in the default handler. And we use the stop matching value when we want only the specific action to be executed for the error. Here, we want only to show the alert. We don't want to redirect to the login screen since we are already here. So we use the stop matching. So this is basically a way to override the error action. And we also add the custom sign-in error in order to show the invalid email message. And this is the only code that we need to write in order to add error handling to our login screen by using the default handler. Now let's try to add error handling to our compose email screen by using the default handler. So at the point where we unwrap the error, we create the default handler, and we add the always closure in order to always show the message that the draft has been saved. And this is the only piece of code that we need to write in order to add error handling to our compose email screen. All other cases are handled by the default handler, which is pretty awesome. So what we get to is to avoid all the boilerplate code, avoid the repeated code, and since we have a standardized way of handling the errors, we eliminate the amount of thought that we have to put in each case to the absolute necessary. So the basic advantage of this API is that it provides a very structured way to handle the errors that can be applied both globally, but also customized conditionally per case. So, yay! Some additional features are error matchers. Error matchers are an alternative to matching closures that are used to match errors with actions. So an error matcher is basically a protocol with only one function, the matches function, that returns a Boolean value. Error matchers are very useful when we want to reuse the matching logic across the app. And error matchers can be combined with and or operators. So for example, we can create a not connected to internet matcher and a connection lost matcher and combine them in order to create the offline matcher. Another feature are tags. Tags are basically a way to group matchers together and characterize them with a memorable alias, like offline. So we create a tag at the point where we set up our default handler, and we can use it later on in our controller in order to refer to the offline error. Finally, we have some extensions that provide convenient methods for HTTP errors, like the alarm-of-fire extension. Actually, before, in our example, we cheated a little bit when we used the on HTTP status 401 method that was not part of the standard API. A similar API is part of our alarm-of-fire extensions. And everyone can create their own extensions for the networking library they use. So, to sum up, no one can deny that error handling is really a vital part of a good user experience. And it can get pretty cumbersome, especially if you want to consider all cases. But if you use the right abstractions and you really design for errors, you can minimize this friction. So, even if there are many error cases, it's nothing you can handle. And this is the link to our open source project in GitHub, and our Android developers at Workable have also implemented the error handler in Java. So thanks everyone, and we'll be available for Q&A afterwards.
Thank you.